All right, welcome back there, gang. It's lesson 5.4, Algebra of Functions Independent Study is what it says. This is mostly we'll be talking about a sheet that you have in your your package here, and this video has two goals to it. One is to take up this 3-minute review, which will help us get onto this in-class project, 1 day or 3/4 of a day project. Um, and all this video will explain it. So here comes a 3-minute review taking up. Number one, a function is even if, well, there's two things that you could say, right? It's symmetric in the x-axis, or sorry, symmetric in the y-axis. Right? There's an example right here. This is a good one. Right? It's even when you can flip it this way. And the more algebraic rule is that, remember, f at x is equal to f at minus x. And what that's saying is it doesn't matter whether you put in a positive or a negative number, I'm going to get the same output value, f. And this is the algebraic version of even. Odd functions are symmetric, and there's a couple ways that people talk about how the symmetry of an odd function, but it's symmetric. I kind of call it about the origin, and I know that you might not think of it this way, but it's kind of this way, that about the origin means if I have a point here that's on the graph, and if I go straight through the origin, same distance, I'm going to be at a corresponding point on the other side of the graph, right? This is an odd function. Lots of people also say that it's symmetric, about both axes. If I flip it this way, then it'd be kind of like this. That's the halfway. And then I flip it this way, and I got the original graph back. Some people think of it that way, and you're welcome to do that. Again, the more algebraic way to think of an odd function is that this statement is true. And notice, one way to think of this is the original graph is the same thing as when I do a horizontal flip and a vertical flip, and that's the symmetry that we were talking about right there. Okay, great. Even function, odd function. This is going to come into play in this investigation come up today. 3 even and 3 odd functions. So even functions, ones that are symmetric about the y-axis in the direction of x, and some odd functions. Well, what are some? Y equals x squared is. Y equals the absolute value of x is, right? Remember that one? Yeah, that was back in unit 0, but that's an even function. One of the trig ones was, which trig one was even? Well, sine function was, right? Or the cosine function, rather. Because it went like this, but it also went like this. This is y equals cos x. Y equals cos x. Even function. Odd function? Well, this one that I had here was x cubed, right? Or kind of looked like x cubed. And actually any odd function polynomial or odd degree basic function, x to the 5th, x to the 7th, all those ones. In fact, this is my favorite maybe because it's nice and easy. Y equals x is an odd function. Trig function, sine x is odd, right? Sine x is odd because it's the same down here as up there, right? And it keeps going. Those are even, that's odd. And it says show, this is just maybe a reminder, how do I show that a function is odd? Certainly I could graph that, but that's only, maybe it looks odd. But I can, what is it, sine x plus x cubed, is that what we got? Plus x cubed. If I want to show that this is an odd function, then I want to show, required to prove, that f at x is equal to negative f at negative x. So how do I do this? If I want to prove something, let's split it into the left side and right side. Why not? Left side is just f at x. Right side is negative f at negative x. This is just sine x plus x cubed. Now, how do I do this? Well, I'm going to have this negative sign out front, and f at negative x, I'm going to put it in here, is the function f, which is this. Right? Here's the function f, and I suppose I didn't need that bracket way out there. It's not a huge, long function. I take out the x and I put in minus x. Right? I take out the x and I put minus x. I might even change that to a different color just so I can see what I've done. I took out the x and I put in minus x. And early on, when we did this unit 0, we talked about even odd functions. We just had polynomial functions, right? And I know if I take negative x and I multiply by itself an odd number of times, I'm going to have x times x, there's the x cubed, but negative 1 times negative 1 times negative 1 times negative 1, negative 1, an odd number of times is going to be a minus. So this part here is that minus out front, right? It kind of comes out of the brackets. Now, what's going on with the sine function? Well, we knew back in unit 0 that the sine was odd from its symmetry, but that's actually one of our rules, right? That's one of our trig properties, that this is true. Is the sine of negative x is equal to the negative sine of x. Right? That's one of our trig properties. That's one of the things we learned in the trig unit. Right? This is true. Why is it true? Well, because I memorized it, but we could think of it this way, right? Sine is negative down here, and so I know if it's a positive x there, the positive x, this thing would be positive, but then I need to make it minus so that the cast rule works, right? Sine's actually positive in this quadrant, but negative down here, there's negative x right there as far as the rotation angle, and so this thing's true. But now I got minuses and pluses all over the place. Well, I just want to simplify, so I'm going to distribute that negative sign through the brackets, and I get negative times a negative is a positive, and look what I got. I got left side equals right side, which means this is true, and that function is odd. Okay, on to the investigation, the independent study. So we're going to be splitting you up into groups of 4-ish, and your main group that you have is going to be the ones with the same card value. So you're going to get a card. Let's say it's the Jack of Diamonds. You're going to get the Jack of Diamonds. Well, not everyone will. Your main group is the ones with the same card value. So you're going to get together with all the jacks. That's going to be your main card value. But several of your classmates with the same suit as you have the same assignment. So you've got a page worth of questions, and your group, your jacks group, is responsible for doing all the same, all of the questions, but you as a diamond only have to do a certain amount of them. So you have to do like 1 and 5 and 9 and so on. You only have to do a few of the questions. But all the other diamonds have to do the same question. So even though your jacks are the group that you'll be handing in this little project with, you'll probably be working with the diamond people. Do you understand what I'm talking about? If not, I'll explain it in class. At the end, you'll return to your main group and collect up your conclusion sentences. So all this work you'll do on a separate piece of paper, and then your group will have all the work together, but you really just are interested in the conclusions. So, for example, the conclusion for the very first investigation, you're supposed to see whether the instantaneous rate of change of the sum of two functions is equal to the instantaneous rate of change plus the instantaneous rate of change of the other one. Can I just add the two IROCs together to get the IROC of the sum function? So this is going to be true or not true, and that will be one of your conclusions. So this will be probably the first sentence. One of these two things will be the first sentence in each group's final project. Notice some investigations have more than one conclusion. And the homework is just to finish this in class. And it is a bunch of work. You need to focus and get into it, okay? hopefully you kind of understand what's going to be asked of you today. But that's it. That's it. There is an FAQ, but it's this independent study that's the main thing today.